Hello and welcome to this Pandas and Python overview with me, James from Matplotlib Software, where we're going to be looking at some slides initially around why we use Pandas for data analysis, what it is, Pandas versus Excel, and some items on series and data frames. We'll then move into sort of coding demonstration on reading files, creating series and data frames, filtering for information, conditional statements, and then we're going to wrap it up and actually visualize it with Matplotlib and then look at editing those visualizations. So I'm going to duck out here, but as usual, if you like the content, feel free to like, comment, subscribe and share. Thank you. Okay, so first of all, we're going to go over some overview slides. If you do want to just go straight into the code and look at some of the functionality, head over to around 4 minutes. But for anyone who doesn't or hasn't used Pandas, I'm just going to go over this. Feel free to pause and read at your own leisure. But essentially, Pandas is the premium Python library for working with data and data analysis, cleaning data, manipulating it. It's a powerful library for anyone who needs to get results quickly. There is a steeper learning curve, obviously, than Excel because it's much more powerful and it's also utilizing a coding language, Python. But if you want to work with tabular data, data from database, CSV, Excel, JSON, so on, this is a tool for you. So here's some reasons to use Pandas. It's fast and efficient for manipulating and analyzing data. So yeah, we can perform calculations and load sort of medium to large data sets very easily. Data from different file objects can be loaded. We can handle missing data, rows, empty rows, cells with missing data. In Excel would be the equivalent. Columns can be easily inserted and deleted from data frames. Very easy to maintain and manipulate things. We can merge or append data, columns or series as they're known. Flexible reshaping, so yeah, you can change the way that you view data from sort of row, and we're going to look at some of this and we can iterate through data sets. And in general, very powerful and very flexible and easy to use. So Pandas versus Excel. Well, if we need to make the comparison, we can say that Pandas operates in the back of Python, so it's extremely fast and efficient. As we see here in Excel, once you exceed 10,000 rows, performance slows. But Panda has no real limit, handles millions of data points seamlessly. What I would say is Panda is very good sort of in between small and large or big data. So right in the middle, medium data sets and moving on to large data sets, it excels. It has no limitation to the number of data points and it's limited only by computing power. But we can use these interchangeably. You know, you can use SQL, Pandas, and Excel interchangeably. Excel for small, easy analysis with the GUI, and Pandas can take more of the power and do more of the legwork. So, two essential components of Pandas. The series data structure is essentially like a column in Excel. That's how you can think of it. And a data frame, we say here, is a 2D object that can have columns of different types. Well, again, if we want to simplify this, as you can see in this great illustration from learndatasci.com, a data frame is essentially a table. It's tabular data, and the series is the columns that make up that table. And we'll look into this in our demonstration as well. And we can get inputs from files, Python dictionaries, Python less series, and even another data frame. So incredibly powerful. To start us off, I'm actually using Google Collaboratory, which is very similar to Jupyter Notebooks, but you can actually just Google Colab. If you've got a Gmail or Google Drive account, whatever, you can actually use it. And it's particularly useful here. Like you can see, I've commented the steps we're taking if you want to evaluate things row by row. So in a data analysis or data science, when we want to break the components apart, it's very useful. So like you would in Terminal or the command palette, CMD, you can just pip install Pandas and you can do it locally here within our session. So you need to do it there with the exclamation mark. And import Pandas as PD. So remember, we can use an alias in Python. So we can say as to save us essentially typing out Python. Now the first interesting command we've got here, we can just type print, open our parenthesis, PD dot 2_ version and 2 more. And that gives us the current version of Pandas that we're using. So a nice easy way to ease you into this, but you can see it's sort of minimal code and you can get some good results already. So let's say we want to create a simple Pandas series from a Python dictionary standard format. So we can do sales is equal to, and open our curly brackets, and we need January, February, March, that's a sales month, in our quotation marks. And then we can use another variable, SRS is equal to a series, and we pass through sales, and when we print that, you see we get essentially a column format, but it's not that sort of two-dimensional, tabular, nice data frame data. So we're going to see how we can do that next. But series, remember, is one of the core principles, and then we're going to now look at data frames, the sort of the big idea behind pandas in Python. Okay, so as you can see here, I'm actually creating a data frame from two series that I'm creating within a Python dictionary, and I've got lists here. You can see that by the square brackets. So I've got a month list with my months, January, February, March, and sales with just some arbitrary numbers. And after that, I can pass through the data frame variable, and I just want to load that into a data frame. So I can use pd.dataframe and pass in data, and you'll see I get that nice tabular style data. And this is a data frame. So I also get that index 0, 1, 2. Remember, when we're using Python, we count from 0. That's important to remember when you're trying to locate things within pandas. Now let's say that we want to load CSV or Excel files into data frame. Very easy to do. We can create a variable, df short for data frame, and we can say pd.read_CSV. And then we actually use this folder icon because we can store these locally. And you can change this, so it could be pd.read_Excel, exact same, and you would use maybe the XLSX workbook extension. So easy to do, and you can actually, I use things like Colab for people because this is aimed at beginners and sort of intermediate, so it gives you nice tools to do things quickly without having to set up IDEs. So we can just store our files in a folder. Equally, if you were doing this in another IDE, you could just copy to the path from Windows. So we can actually also load JSON files into a Python data frame. So one thing that's important to note is that JSON objects have the same format as Python dictionaries. So if I go through this, you can see how this is sort of going to pan out. We're giving it an index, 0, 1, and 2, so on. And then we're just going to separate those with commas for month. And then we can go through, we could do whatever we want, sales and profit. And this is we could also create a data frame this way, because quite often if you're working in data science or data analysis, you might have actually some very large pieces of data in JSON files. So it's important to know how we would potentially import these into a data frame if we want to sort of quickly analyze some data powerfully using Python. So now that I've created this JSON, quite often you may just copy it through. We can assign to the data frame the pd.dataframe function and pass in data, and that's going to pass in our JSON. Now let's see how we could view the top and bottom rows of a data frame. So let's say I've got this mock sales September, I just got this off Kaggle sample sales data. What as standard pandas will do is it'll truncate the views, so you'll get the sort of top 5 and the bottom 5, because obviously it's not performant to load in 12,000 rows of data and many more in some cases. So you can actually use dataframe.head, df.head, after we've assigned a data frame, and we can view however much results we want. So it could be 3 or 50, and again at the tail you could view the bottom 2 results by using tail and passing through a value. So now one standard feature we saw, we get the truncated top 5 and bottom 5 rows displayed. So we can actually we can assign a number of max rows to be displayed. So here I'm saying 12,000 because I know there's nearly 12,000 rows in my data set. Obviously not the best for performance, but you can do that if you want to see the full extent of the data. So that's a way to get around that standard sort of truncated or minimal view that you get when you pass in a data frame. The next thing that we want to look at is, this is really useful, we can actually print the info about the data frame with very easy, and we can just pass in df.info into our print statement. And you'll see we get information such as the number of entries. If there's null values, we can view it by columns, so specific data, so that's helpful. And we can also print statistics about a data frame, which is useful as well. So we can say df.describe, and here we get certain statistics here. Again, count, unique entries, frequency, things like that. So valuable tool there that we have to use when analysing our data. Now, what if we want to potentially display a single column? Well, we can do that. We can select print. We can use our data frame variable, and product is a column name. So we can do that, and we could go ahead and we'll get the index and the product. So that's useful. Also, potentially we want to see, products, but we maybe don't want to see 12,000 odd entries. So we can limit that as well by selecting a certain amount of rows, or we could select other columns, and we can really choose how flexible we want this to be. So we could choose the product and the price of each there. So we've got the index, the product, and the price of each. So we've got single, and then now we've went through to multiple columns. And then what we can also do is we could select index 0 to 10 and show those rows. And then now we're starting to mold our data and see exactly what we want to with very minimal lines of code. We can also use the iloc or the integer location function here, and we can print the data frame, use the iloc, and pass in row 1, and we can see in a different sort of format the order ID, product, and so on in a nice digestible format. Alternatively, if we wanted to see from index 0 to 50, we can do that as well very easily by going through the integer location function. Let's say we want to display a specific location. I'll quickly pass in the data frame just so we know what we're working with. And then we can actually choose a row and a column potentially. So what we could do is we can quickly just show 0 to 5. So we will get all of the rows between index 0 and 5. And now we can display almost like if you think in Excel or here a specific cell. And as long as we declare a row and a column, we can do that. So we can use the df.iloc, and then we can display, let's say we want to use from row, let's say 2, and then we want column 1, and that's going to give us USB-C charging cable, because remember, your columns and your rows start from 0, so you need to be careful there, because in an ordinary world you may have chosen 2 to get the USB-C charging cable, but remember, you're always counting from 0 when you use Pandas or Python and sort of programming in general. So what we can do now, we can actually create a for loop, and we'll look at the output. So we can say for index and the row in the data frame dot iter rows, so iterate through rows, and we want to print the index and the row. And you'll see it takes a while because we haven't specified a range, we've just given it the whole value, but you get the data in a very digestible format. So it's in chunks instead of rows, and you can view the data in a different format, and it's just a way of sort of reshaping our data, and it might be preference of yours to look at it this way. So the next thing that we can do is we can actually return results based on conditional statements. So let's say if we wanted to look at results based on products, and obviously we're going to look at one example with time constraints, but you could actually be looking at, you can implement and or, you can have multiple conditional statements to sort of filter or return specific values. So what we could say here is essentially we're saying we want to look at the product type within our data frame, where that product is equal to, we could say wireless or wired headphones, and that's going to return all of the values and the indexes where that's the case. You could obviously specify more columns and sort of shape that however you like. So we can create a new data frame. I've just copy and pasted what we had before above in sort of a manual data frame with dictionaries and lists. I'm just going to add a bit more data, a few more months, bump that up to 6. And as well as sales, we could add in a profit column. And then we're going to look at some ways where we can look at correlation, and then we're going to sort of look at modifying and then plotting our data to round it up. So there we go, we have our data frame. Now you can actually use df or data frame, whatever your variable is, .core, and that's going to show the correlation between numeric columns. So obviously sales and sales is going to throw up a full correlation, a one-to-one relationship, and so is profit at 1. But you can see that profit and sales have a very strong relationship where they're at 0.97, which is pretty close to a one-to-one relationship. And what you can assume by this is that each value will increase with the other. Now, if you had a negative, that doesn't mean it's a bad thing. If it was negative 0.97, it's very strong. It just means one value may decrease with the other. Obviously, if you have a value of 0.2 in the correlation returned, it's not going to be a strong relationship, and you're not going to see much correlation at all. So important to understand that. And if you have several fields of numeric value, it's a really good function to start analyzing your data and looking at it with. So if we want to delete a column, and you'll call this a dropping, if you come from a SQL background, you'll also be familiar with this, where you use drop to specify deleting values or a column. And what we can do here, it's very simple. We use our data frame and we just use the df.drop. And when we print the new data frame, you can see that we specified we wanted to drop profit. It's now gone. However, we could append a new column to a Pandas data frame if we liked. So we're going to look at how we can do this now. So I'll assign some arbitrary numbers by using df, my data frame.assign, and then profit, and then I just have a list. And when I click data frame again, as simple as that, we've appended values on. Very simple, obviously, because we've got a small data set, but the principles remain the same, and it's nice and easy and flexible. And if we want to rename columns, this is quite an interesting technique here. You could use columns, and then we just need the equal sign, and then we can use our curly brackets, and we basically specify the old column name within quotation marks. We use a column and we provide the new column name. So again, very simple and flexible in how we do this, all from our code. So it's nice not having to interact with GUIs sometimes. So we can replace profit with total profit, and then when we click on that, we'll see that that is now reflected. So how do we save a modified data frame? Well, this is actually very simple. To do this, there's an inbuilt sort of way to do this in Pandas. So I'll print my data frame, and I can actually go ahead and print my new data frame by in the example above. I'll just assign it to a variable. So I'll just say the df is equal to that new data frame, and I'll print that, and you see I get the new total profit reflected. So if I print data frame below, because all it does is it updates the variable. That's why I keep renaming it df, because it's going to update. It saves us having to keep track of loads of different variable names. And remember, we're just using df short for data frame. So we can actually say df.to_csv, and we can pass in what we want to call this. So you can call it whatever you like. And then what we can do after that actually is we can say that the index is equal to false. And what that's going to do is when we save our CSV file, it's just going to give us the month, the sales, and the total profit without that index rows, which is nice when we're not actually sort of looking at it within a Pandas context. So we can run that file like you would in any IDE or text editor. And what's great is it's stored locally in Google Colab. So again, if you're a beginner to text editors or IDE, just do this online. And you can see it's saved here, and you could download that if you liked locally to your system. So very handy, great feature. We've already looked at filtering data with our conditional statements in enough depth for an overview. So to round this up, we'll look at how we can plot this simple data frame that we've created. And in short, it's very simple. We can use a library called Matplotlib within Python. So we're going to import Matplotlib just like we would with Pandas. We basically, you may need to install this if you haven't with your pip install, and .pyplot as PLT. Again, I'm using an alias just so it saves me a bit of typing time. And all I actually need to do here is we'll pass our data frame through and then say .plot and our parenthesis. And what's going to happen now, we get our sales and our total profit nicely plotted. Now, we do get that bit of details at the top. So if I just type in plt.show, that's going to give me the actual visualization without those details at the top of our graph there. So lastly, I'll quickly show you. It's very easy to edit this. So maybe I want to add an x-axis, and I'm going to call that month, and the y-axis, let's say we're going to set that equal to sales. Great. And then what we can do is we can change the kind of chart. So you could have bar, you could have scatter. If you say bar H, what that's actually going to do is give you a horizontal bar chart. So there we go. Cool. I've got the sales as I planned and the month there. Great. And then I can change the color to red. And then what I might want to do is change the title to something like company revenue figures. And that's going to change there as well. So we've got a nice title, and it was very easy to edit through our visualization. And maybe lastly, I want to add a label to the x-axis. So I could say values and our value. And there we go, very simple to edit it. So we've actually covered a lot, an overview of Pandas, some of the core functionalities, creating visualizations, and show you how easy it is to take your data, mold it, explore it, clean it, and wrangle it, and get some really powerful insights. So obviously there's a lot more you could learn, but hopefully this has fostered enough creativity for you to go away and do it. And as usual, if you like this content, please feel free to like, comment, subscribe, and share. Thank you.